Hi everybody, welcome back. And in the second part of this video lecture on section 6.3 on population proportions, we just want to do some of the examples in our notes. Okay, so in this first example we have a random sample of 532 people shows that 307 of them support candidate B. Find a 95% confidence interval for the proportion of the population supporting candidate B. What is the margin of error? All right. So we can see right away that our sample size is 532. Okay. And our p hat will be, we define, with the p, we want p to be the number of the percentage of people that support candidate B. So p hat from our sample would be 307 divided by 532. And this turns out to be 0.577. And then q hat is 1 minus p hat, which turns out to be 0.423. Okay. So now it's pretty easy to compute that np hat and nq hat are both bigger than 5. In fact, they're way bigger than 5, right? And np hat would be 0.577 times 532. That is 307. Back 307. That's certainly greater than 5. And nq hat would be, in this case, 423. And that's certainly bigger than 5. So we're good. We can go ahead and proceed. All right, now we want a 95% confidence interval. So C is 0.95. So Z sub C, we're beginning to memorize that as 1.96. Okay, we don't have to go to the t-distributions because we're working with normal distributions now. And so E sub C is going to be this 1.96 times the square root of 0.577. That's p hat. Q hat is 0.423 all over 532. Okay. All right, now it's very important when you're doing this, this 532, this denominator is part of the square root. So what I would suggest is you do multiply these two numbers, then divide, then take the square root, and then multiply by 1.96 in this case. And when you do that, you get 0.042. Okay, so that is your margin of error. Okay, and so the endpoints of the confidence interval, p hat, we said is 0.577, so we minus 0.042 and 0.577 plus 0.042. Okay, this turns out to be 0.535 and 0.619 respectively. And so our confidence interval says that p is between these two numbers. And so we say with 95% confidence that the percentage supporting candidate B is between 53.5% and 61.9% with a margin of error of 4.2%. Okay, that's what we say to the layman when we give the results of the poll of a calculation like this. All right, let's look at example 2. In a survey of 1,100 U.S. adults, 782 think that police officers should be required to wear body cameras on duty. Find a 99% confidence interval for the proportion of the population who believes this. What's what's the margin of error? Okay, well, in this case, n is our sample size is 1,100, and p hat is 782 over 1100. And this turns out to be 0.711. And then Q hat is 1 minus P hat, and that's what is it, 2.289. All right. I won't write this out, but it's easy to check that NP hat and N times Q hat are both way bigger than 5, so we can proceed from there. C is 0.99 in this case. So Z sub C is 2.575, and our margin of error is 2.575 times the square root of 0.711 times 0.289 all over 1100. Okay, which is equal to 0.014. Okay. Now notice that this is quite smaller than before, because even though normally you would think that if we had we need a bigger margin of error because we have a bigger confidence interval, but our sample size is much bigger than what we had in the previous example. So that's why this number here, the bigger number, the denominator is sort of canceling out. The fact that this number is a little bit bigger is canceled out by the fact that this number is bigger. All right. So P hat. So we take find the endpoints. We 0.711 plus 0.014. That is 0.725, and 0.711 minus 0.014 is 0.699, or no, 697. Okay, and so our interval says that P is between 0.697 and 0.725. Okay. Okay, and we would say that this would be in layman's term, we would say that the percentage of people who support this is 71% with a margin of error of 1.4%. All right, moving on to the next example, example 3. I think you guys are smart and you can figure this out on your own. I would suggest you pause the video and work this on your own and see what we get. Okay, so hopefully you got this. P hat turns out to be exactly 0.68. Q hat is 1 minus 0.68, that's 0.32. N is 1550. And since C is 0.90, Z sub C is 1.645. Plugging everything in, we get a margin of error of 0.019. And adding and subtracting stuff, you can see that, wow, I made a little mistake myself, but I corrected it, and we get our confidence interval says that P is between, the percent is between 0.661 and 0.699. That's approximately so that's the confidence interval for the proportion of the population who is using Facebook, which is now Meta, I guess. I don't know. I don't care. All right. So on the last example, we're doing something a little different. You wish to estimate with 95% confidence the population proportion of the U.S. adults that approve of Congress. Your estimate must be accurate to within 4% of the population. Find the minimum sample size needed if A, no preliminary estimate is available, or B, a prior survey showed that 25% of U.S. adults approve of Congress. Okay, I know you're thinking that's kind of high, but oh well. All right, so the preliminary, so in this case, the margin of error is 4%. So, but we don't write E equals 4. We write E equals 0.04. Okay, and see, this case C is 0.95, so Z sub C again is 1.96, and we're trying to find what N is. There's no preliminary estimate is available, so we're going to let P hat and Q hat be 0.5. Okay. So in this case, we need N to be greater, N is equal to 0.5 times 0.5 times 1.96 divided by 0.04 squared. And when we square that, when we calculate this all out, this is 600.25. And so because N needs to be strictly bigger than this, really. So we want N to, so we need N to be at least 601. We don't say 600 because then that would be less than this. All right, now let's say if we do we know that a prior survey showed that 25% of U.S. adults approved of Congress. So now we can replace for P hat, we can let P hat be 0.25, and then Q hat will be 1 minus that, which was 0.75. And then doing everything else the same, N has to be greater than 0.25 times 0.75 times 1.96 divided by 0.04 squared. And that turns out to be 450.18 something. So we want N to be at least 451. Okay. And you can see that having a previous estimate available or a preliminary estimate available actually narrows down your sample size. All right. So this is how people determine the sample size when they take they first choose a margin of error, then they choose then they fix the sample size. And hopefully these formulas, you get comfortable using them, and that's all for confidence intervals. And then so I will see you next time. Take care.